Okay, this is another example on two-step converting. We're going to convert from 85 nanograms to a unit of picograms. So let's start here. Give me my pen. And we need to establish a relationship between nanograms and picograms. So in order to do that, we have to have a relationship between nanograms, 2 grams, then to picograms. Let's click you out. Now, the first thing we want to do is write out a equation or a equality for nanograms to grams. So as I've always been saying, we put 1 with the prefix nano, and it equals its prefixed equivalency. Nano means 10 to the minus 9, and that's going to be grams. So our second step is to make a relationship between pico and grams. So we put 1 with pico because it contains our prefix, and 1 picogram is equal to 10 to the minus 12 grams. Okay, so we've been doing things like this: 1 nanogram over 10 to the minus 9 grams, and 10 to the minus 9 grams over 1 nanogram. The same thing on this side: 1 picogram over 10 to the minus 12 grams, and 10 to the minus 12 grams over 1 picogram. These 4 fractional ratios are going to use to convert the problem. As I said before, when you get particularly good at this, all you will need is your conversion factor equation. You'll know what to put at the top and what to put at the bottom. You won't necessarily write these 4 ratios out. You'll just be so good at it that you can just write out your equation as a conversion factor and go from there. So let's see what we have. We have 85 nanograms times, so my relationship between nanograms to grams, let's see, I want 1 nanogram at the bottom, and that's going to be 10 to the minus 9 grams at the top. Nanograms cancel, and we want to have a relationship between picograms and grams, where I want my picogram unit at the top and my grams unit at the bottom, so it would be this conversion factor. So what do we have here? 10 to the minus 12 grams over 1 picogram. And grams cancel, so that gives me 85 times 10 to the minus 9. Now be careful again, as I said in class, we have to remember our rules for algebra. When we bring up an exponential from the denominator, we change the sign of the power that it's raised to. So this is 10 to the minus 12 in the denominator becomes 10 to the 12th in the numerator. Okay? Now, I have the same base 10 right here, the same base 10 right here. I'm multiplying the two, so my rules of like basis said that I can have 85 times 10 to the 12 minus 9, or minus 9 plus 12 is the same thing, gives you a exponent of positive 3. Okay? Now, to put this in scientific notation, I would want to move that one place to the left, and if I did, that would increase my power of 10 in my answer. So that would be 8.5 times 10 to the 4th. And my unit is picograms. So get familiar with step by step exactly what we need to do in order to solve these problems. It's quite simple once you've practiced enough and you've studied and learned your metric prefixes. If there are any questions or comments, please bring them to class.